Awesome. Well, first, thanks for joining us, everyone, as usual. Please follow us on Twitter. You guys know where the meetup is, but if we have any announcements, we'll definitely have them there. Speaking of announcements, we are going to have an upcoming presentation in November. It's going to be Say No to J&I by Carl Dia, I believe. And we're actually going to raffle off an IntelliJ license then. So please sign up and attend. Just signing up isn't enough, so please make sure you attend if you want to have a shot at that. And as I said a few minutes ago, we are not going to have a session in December, but we will be back in January. And we're going to be resting and coming up with our plan for next year, and also looking into getting all of our sessions for this year uploaded. But yeah, with that, I am happy to have Billy with us here. Billy was actually the last presenter we had in person, so that's kind of exciting to have him back. But yeah, at this point, I'll just hand it over to Billy.
Great. Thank you, Renat and Teresa. Yeah, it's unfortunate. Yeah, last time I spoke at Pittsburgh Jug was in person, and actually make it my screen shared. There we go. Yeah, it was in person. That was January. Yeah, that was January of last year, and long time ago, like just a very long time ago. Yeah, it's kind of funny. I don't know, maybe this whole COVID-19 thing is my fault, because at the end of 2019 I was doing a lot of travel, and I mean, we're being completely exhausted by it all and thinking like, I'm not going to travel as much next year. Well, you know, it's kind of the Simpsons monkey paw effect going on there. So sorry if I'm a bit more to blame for this all. That said, let's go ahead and get into my actual presentation. As Renat mentioned, my name is Billy Korando. I'm a Java developer advocate with Oracle, and you can find me online at Billy Korando, where I spend way too much time on Twitter. So today's presentation is to Java 17 and beyond. So a few quick important notes. I'm a very demanding speaker. I demand that if you have any questions during the presentation, please ask. I would say maybe ask in the chat, and I'll have that popped up here just that way, because Zoom, when someone pops in with talking, it can kind of be a little weird and distracting, but I will be definitely monitoring the chat. I have it up on my screen. So if anyone has any questions at any point, definitely ask, and I'll be happy to answer them. If you need more clarity, or want me to go into depth, or whatever it might be, feel free to ask. Additionally, if you need to reach out to me, you can also find me on email as well. So at billycrandall@oracle.com. And the most important link you need to know about is the link to my slide deck, which is at my GitHub. So definitely just go to that as well. Don't worry too much about having to write down any links that I might have in here. You can just get them all in just a single location. So with that said, what is the agenda? We're going to be covering, obviously, Java 17, but we're going to be looking at the new language features, new runtime features that are being added. And this is, of course, focusing kind of between from Java 12 to Java 17, primarily of what we're going to be covering. Then we're also going to be covering deprecation removals and other changes that people should know about. And then after that, we're going to be looking a little bit into the future, but it's going to be kind of coming in the next year or two to Java, some of the key changes that are coming. If you leave this presentation also with an intense desire to know more, so one thing I do is a day or a weekly 1-minute video called Simple Java, and it's a 1 minute on just various Java features that maybe are new and upcoming, or people maybe don't know about yet, but check it out. And a lot of what I'll be covering in here, I'll cover in a bit more depth. I'm actually in the process right now of migrating away from my GitHub. But for most part right now, most of the articles I covered will be able to find here at my GitHub location as well, which I think also generally has links to the videos as well. All right, so let's get into some of the new language features that have been introduced to Java in recent releases. The first I want to cover is text blocks. I think this is going to make many Java developers' lives easier because, well, almost all of us at some point, and really frankly multiple times, will have had to kind of work with a formatted or a markup language directly within our code. And so here's a very simple JSON message that I maybe have that's, maybe describing my name and like my occupation, my Twitter handle. And because we're familiar enough with this code and what it looks like, we can kind of read what's going on. Of course, it's very simple, and there's a whole lot of cruft going on here with the tab marks and new line and all the escapes for all the new lines and the pluses. I mean, like I said, we can kind of read it, but it's not too easy. And of course, when we're talking about something a bit more complex, where there's going to be maybe some nesting, some depth to this, like JSON or HTML or XML, it quickly becomes unreadable and incredibly difficult to maintain, where you could easily forget to put like a quote mark or a colon or or a comma or something in there, and you're just going to have to like go through and figure that out, and it's terrible. So Java 15, always kind of forgot to mention. So this was added in Java 15, and the JEP, which stands for JDK Enhancement Proposal, is 378. And what that means is JDK Enhancement Proposal is when there's a somewhat substantial change being added to the Java, to anything within the JDK, it goes through the JEP process. Substantial is a bit of a loose term, but I think it generally means it's like 2 or so weeks of developer time. Of course, that's the minimum. Of course, it could go to be much, much larger because there's some very large projects being added to that. But these JEPs are a great place to go to, and you can find it at openjdkjava.net/JEPs, and you can read about like the history behind the change, the motivation behind why it's being changed, and then examples of how this new feature is supposed to work. So this can be a really great place to go to really understand these features that I'll be talking about during this presentation in much more depth than I'll be able to go into during this presentation. So that's why I put those in there. So definitely check those out if you want to learn a bit more about a feature you are particularly interested in. So, but back to text blocks. A text block is denoted from a typical string by the triple quotation marks. And so you put triple quotations at the start, you do a new line, a character return, and then a lot of the formatting restrictions are greatly reduced within here. So you don't have to put like the new line character for like these spaces here. I don't have to put any tabs in here. I don't have to escape the quote marks or anything like that. So really what we're going to get is when this is printed out by the code, then this is going to look exactly like how I have it written in the code. So then also like a big thing within this is ignoring incidental white space. So pretty much more or less just what it's going to come down to is where these the enclosing triple quotes, where those are, any white space to the left of that is going to be ignored. There's a bit more rules about that, but more or less you just kind of want to line this triple quotes up with wherever you want a white space to be ignored, or wherever like the left margin is supposed to be. And so that way, as you maybe refactor your code, maybe you move it around into like a new method, or you move it into like a loop or something like that, or if statement, you're not going to all of a sudden get a bunch of more white spaces added to it. But you can look up, there's like a developer's guide to text blocks. They can kind of give you all the different rules around how incidental white space is handled. But all together is, if I was to do a system out.println on this simple JSON message, it's just going to look exactly like this when it's printed out by the JVM. Of course, maybe you need to do some string formatting. You want to, have something passed in, and that's easy enough to do. Like I said, this is really just a normal string. It's just a different way of declaring it. So if I was to put these %s for a string to be substituted in, that works exactly like it would with a quote unquote normal string. And then the last thing I'm going to touch on was text blocks is also, like, let's say you maybe have to have a single really long line of code or long text line printed out. You can ignore a character return by just putting a backspace at the end of the at the end of the line. Just make sure you don't have any other white space after this. So if I was to put like backspace or backslash and then like on a space after this, then the compiler is just going to assume, or Java is just going to assume that you want to have this actually printed out. So just make sure this is like the actual last character within the line. But otherwise, if I was to print out a really long line, it will be all printed out as a single long line by system out print line, or however you're going to have it being rendered. The next thing I want to cover is switch expressions. Again, we've all worked with switch statements, which are defined by like the case and then whatever, the matching case is supposed to be, and it's a colon. But, there's always some frustrations around that. The biggest one being the fall through by default. So it's annoying in two ways. One, it's often the source of bugs where you forget to add a break statement, and then, something goes wrong in your code, and then you, of course, then have to go in and fix it. And then it's annoying also because you're just going to have a bunch of break statements within that code, which is just really distracting to look at. So what we added was switch expressions, and they're denoted by having the arrow operator. And what this means then is only the code to the right of the arrow operator is then executed. So that way there's no fall through by default. So that way we don't have to put a bunch of break statements within our code. You can also have switch expressions evaluate out to a value. So here we're going to have like result coming back from, and it's a string. And for each, whenever a case matches, it will return then this string value for it, which is a lot nicer than having to, within each case statement, assigning value to it. And also each case statement, it must evaluate to either a string or evaluate to either an expression. So just whatever here, it can also be a block, or it could be a throw statement. If you're returning value from it and you're having it execute a block of code, you must have a yield statement within it, which then returns whatever value from that code block. But that way, for example, here with like this default, I will print out a message saying like, hey, your selection's invalid before returning a value, just, to give a message back to the user perhaps. Now, you may have noticed in all these previous switch expressions, I always had a default case. So an expression, it must evaluate to something. So for the vast majority of cases, at least right now in your Java code, that means you're going to have a default statement within your code. But if, for example, you have you're switching across an enum, if in your switch case or your switch expression, you cover all of the different constants within that enum, well, that's exhaustive. So you don't actually then have to put a default case within it. And we'll actually get a little bit back later, I think a bit into the beyond, as to how some of the changes coming later in Java, that right now it's really only with enums where you could do a default, or you may not need a default, but there might be other cases where you may not need to use a default as well. But we'll touch upon that a little bit later. The other big story, again, though, it's going to be coming in beyond, but this is the first instance of it, is pattern matching for instance of. So again, another thing and another frustration for many of us as Java developers is when we're doing instance of, like, we have some sort of value coming in, it's maybe coming in from a remote source, and it's this defined type is just not definitely known by the compiler. So we then have to do this if instance of, and it's like string. Okay, great. We know it's a string. So we're going to set it to this whatever string variable, and we do the cast, and then we can actually use it. It's a bit of writing here, and then there's just always opportunities and all that writing to maybe add a bug or something in there. So with now pattern matching for instance of, it will take a pattern variable. So if this evaluates to true, this actually instance of string evaluates to true, then it'll automatically apply it to this flow variable, and then we can just use it later on wherever this is definitely true. So what this is called is flow scopes. And so what this means is, like, again, we can kind of see it in a little bit larger chunk of code. If actually a string evaluates a Dynamo string within this if block, and 90% of the time, this is really how we're probably going to be using it. We'll be able to reference that value or that variable. But once we leave that if block, then that will no longer be in scope. So if you do need to use this variable later on, you do need to assign it to a variable at the appropriate scope for wherever you're going to be using it. And we can also kind of, again, see it here in this Boolean. If I was just to have an evaluation block here, it's only going to be available just within this evaluation block. And once we leave it, it will, again, not be available. Of course, obviously, with an R statement, by necessity, this is going to be false if we're going to get here. So this will give, again, a compile error, because this one, now I'm a string, is not in scope, because this would have evaluated false. So this never would have been set. But of course, with an and statement, well, okay, yeah, that would be, by definition, this would only be evaluated if this evaluated true. So this would work. You could have an and statement, say like, okay, only if this ends with an exclamation point would we then, go into the if block. Not that in fact, I actively don't recommend doing it, but I mean, just to show what it would be like, is like if I was to wrap this in its own parentheses and put a not in front of it, then now my string wouldn't be available in an if block, but it would be available in an else block. Or if I was to wrap this again like this above in a not, and then throw an exception if this ever came true, then I actually would have it available outside of the if block. But again, would not recommend doing that, because, well, that would be very confusing to look at and be very easy to introduce bugs to it. So, but that's just to kind of give you an idea what this flow scope is. Wherever this is definitely true, where the compiler definitely knows this evaluation is true, is where it's in scope. Again, 99% of the time, though, it's going to be in the following if block. Yeah, so yeah, most of the time, just make sure you assign it to whatever variable of the appropriate scope to use it later, like in this example. Next is sealed classes. So there's often going to be times within our applications, within our domain, that there's going to be like a certain kind of limited different number of types some super type may evaluate to. So like, for example, like a user, or it's like a pretty common type within pretty much any domain. And within that, like, okay, there could really only be 3 different types. Like it could be a guest, it could be a customer, and it could be an admin. So you can say a sealed class, and then it can only be permitted to be any of these types. And then, but the subclasses, well, they're also free to kind of evolve. Like they can say like, okay, guest here is a final type, nothing else can extend upon it. So like that's like a dead end. Customer, well, we can have many different types of customers. So it could be like a non-sealed type. And so like anything that could then extend across customer, however is needed. And maybe there's like 2 different types of admin, like your normal level of admin, and then like some sort of like root super admin. But like that's only the 2 different types of admin that are available. And so what this looks like in code is you would have the new, I believe it's a reserved type word, or maybe it's actually a keyword, but sealed within the declaration of the class. And then you would say permits the different types of classes that could be permitted. And then these subclasses would then have to declare whether or not they're sealed, or they would either have to be declared as sealed, non-sealed, or in the case of like guest, final. And from there, so like here, admin, as I mentioned, like it's a sealed class, and then it defines what can be extended upon it. Customer, as I mentioned, is non-sealed, so that basically treats it like a normal class where anything can extend off across customer. And then guest is a final class, which of course means nothing can extend off of it. Permits is optional. What you could also do, if you define the classes, other classes within the same source file, either as an inner class, which obviously would be defined within the user class, or as an auxiliary class, so it's at the same level of class within the source file. You wouldn't have to put the permits there. the compiler will just assume then that these the other classes defined within a sealed class of the same source file are then the permitted classes to extend upon that sealed class. The last feature I want to talk about, last and definitely not least, is records. So they were added in Java 17. They're JEPIS 395. I'm not the first person to say it, but if you may, the first person to hear it from me is I think records are going to be the most significant change to Java since streams or lambdas, or sorry, records are going to be the most significant change to Java since lambdas or streams back in Java 8. They're already pretty significant, and then as they get extended or added to in subsequent releases, they're only going to become more significant. So probably the first big win from records from its developers is going to be the significant reduction in boilerplates. So here we just like say have like a simple like this is like within like the like a code snippet that's within the body of a method, and like okay, we have like a couple of like fields that we have to find, and maybe we want to then put those into like some sort of person object, and like it's just like some sort of like throwaway thing that we're not going to really need outside the context of this method. But if we were to define a person class within it, it quickly becomes just dozens of lines. If we also want to make sure we have like things like hash code and equals and toString, it's dozens of lines. And even at the most basic of it, even if we were to remove these hash code equals and toString, it would still be, you know, about 10 or so lines. And that would kind of really break up the meaning of this code when we're trying to read through it. So all of this can be defined into a single line using record, where you define the name of the class or the name of the record. And then this is called the components of the record for it. And then, of course, it works the exact same way as the previous equivalent person class. So records, the goal of them is to be a transparent modeling of data as data. And so it comes with several constraints around that. First, like the superclass is always going to be Java lang record. You can't have, and then also records they can't be extended, they can't be abstract, and they're thus implicitly final. Again, that gets back to the fact that it's a transparent modeling of data as data. We want to be able to read the definition of the record and know that all of it's going to contain within that record. So we had person, and when we allowed something to extend across person like employee that then had employee ID number, well, you wouldn't be able to look at the definition of employee if it's extending across person to understand what's within it. You also don't have to look back to person. So that's why you can't extend it. All the fields are final, but it's only shallowly immutable. So again, going back to this person, like let's say if I had a list or something as one of the fields within, or one of the components within this record, I couldn't switch out the list within that record after I defined it, but I could add or remove items from it, you know, just because, you know, or I could add or remove items from that list. That's not going to be barred by the definition of a record. You cannot declare instance fields. Again, that gets back to the fact that you want to be able to look at the record to be able to fully understand all the data that's going to be in it within the definition of it. And the compiler will automatically generate accessors, hash code, toString, equals will all be automatically generated by it. But you can override the default implementations of these methods. So in this example, like let's say I wanted to like have a prettier way of calling toString that'll be printed out better than like the standard way of what toString looks like. I can just override toString and do that. And of course, I could also add like just whatever method. Like so, if I want to just have it be converted to JSON, I can define a method that does that to convert it to JSON. So this is just a small bit, actually something that you'll see here Monday when my next sip of Java is released. But one of the biggest changes, or one of the most impactful things with records, is how it's going to be changing serialization. if you haven't done too much with serialization in Java, which I think many developers, other than doing implement serializable, at least certainly that's been much of my experience as a Java developer, is just adding implement serializable and then not thinking about it beyond that. But there's a lot of issues with serialization in Java that it's like one of the biggest sources for security holes. It causes a whole lot of difficulties when it comes to, from an architecture standpoint of the architecture of the language itself, of evolving the language. There's just a lot of nastiness within there. Records are going to be a big savior to that because there's like a bunch of quote unquote magic fields and methods that kind of govern how serialization works within Java. It's like read object, write object. I wish I included, let's see if I can actually pull it up here real quick. So yeah, there's read object, write object, no data, read resolve, like all these things kind of govern how we are, come on, there we go, just to make it a bit bigger. So yeah, read object, write object, read object data. So that, and there's a few other methods and fields that govern serialization. And within that, there can be a lot of security issues within that. And then there's also things like where with just a standard Java class, like let's say within this person record, I had a constructor that said like, first name, last name, they can't be blank. So if I was to do this as a class, when that's being deserialized, like that is ignored. So like you could have cases where from within the standard class serialization, where you have like quote unquote impossible objects created, objects that just shouldn't be created because a constructor may be saying like, oh, that shouldn't be possible. But because standard serialization in Java ignores calling a constructor when it's being deserialized, that is possible. That wouldn't be possible with a record because it would actually go and call a object's canonical constructor when it's actually being deserialized. So that is just kind of getting into almost the start of where records going to be beneficial. And then in future releases of Java, which we'll touch on later, there's going to be farther pattern matching added to it, which will make records a lot easier to work with when it comes to building them, taking data out of them, and so on. But we'll get to that a little bit later. So the next I want to talk about is some runtime features, new runtime features and improvements. So one of them is class CDS, or class data sharing. It's been updated a few times. So back in, I think, Java 10, JDK 10, we added what's called, so all the way back in Java 5, we added a thing called class data sharing. And so pretty much what happens every time you start up the JVM, you start up an application, you do Java, your application or your main class or whatever, that's going to start JVM. And at that point, you're going to be loading, the JVM loads off a class or off of your system path, file path, certain core library or core classes out of the JVM and puts it into memory. Of course, that's going to be the same every time you start up a JVM. So if you're having like multiple instances of the JVM, that's an opportunity for optimization. So all the way back in JDK 5, they added that. And, and it asks a little bit when you have like this, like a hello world program, like it saves you a few tenths of a second at startup. But now, of course, once you get anything much more complex of that, which of course is most of what we're going to be writing, you don't really notice too much benefit. In JDK 10, we added app CDS, which allows that same behavior to be actually applied to your applications, where you can define classes that are going to be loaded into off the class path at startup, and you can find an archive that the JVM can load from and then memory map to where if there's multiple JVMs on the same host, they can all read from that, which can also save a little bit of memory. Then in JDK 12 and JDK 13, this has been farther added to just to make it easier to work with. And so pretty much what you can do is start up an application, you say archive classes and exit, and then you give it a name of what this file will be for your dynamic, for your archive, and then you start up your application. And then the JVM will make a mark of like all the classes that are being loaded up and where they're located on your system, and then create a pre-processed file for that. So that way, when you start up the next time, it will load somewhat faster. I kind of tested it with like a Spring Boot application, and like I think it was taking me on my system, a MacBook Pro from like I think a 2018, so like not one of the M1 at MacBooks, but like it took about like 8.5 seconds without app CDS running, and then about 6 seconds with app CDS, if I kind of remember right. So like you can see some savings. Of course, it's going to vary very much depending upon the particulars of your application. And of course, there's a lot of other things, like if you're making calls out to like connect to a database or some other external service, that's probably going to be mostly where your startup time is going to be coming from. But as far as if you're just loading everything up from memory and not making any sort of external calls, like you could see maybe 10, 15, 20% savings as far as startup time. And if you're having maybe multiple instances running from that same host, you will also see a bit of a memory savings as well. But again, that's only if you're running multiple JVMs on the same host. You won't see any memory savings otherwise. The next is there's a new garbage collector, GGC. So right now, the standard garbage collector, our default one is G1. And it's a great garbage collector, and by all means continue to use it. It's a default for a reason. But GDC, and Z doesn't stand for anything. It's just the code name they wanted to give it. It's just a complete redesign of garbage collectors. And so one of the goals with it is that it's supposed to have super low latency, which can be very good for web-based or responsive development. So if you want to make sure a request is always going to be returned back very quickly, ZGC can be good for that because it's going to have no more than a 10 millisecond pause time. And I think a lot of times it can be closer to about 1 millisecond pause time. It can also be very scalable up to terabytes in size. So you can definitely check it out. You know, the low latency, I think, comes a bit of a cost when it comes to total throughput. So if you're running some sort of really big, heavy batch application, like G1 might be a little bit better for that, since it's going to have a little bit higher throughput than what is actually maybe typically possible with ZGC. ZGC is continuing to be added upon. Like right now, this only means something if you're kind of really into garbage collectors, but like it's single generation, but they're planning on making it a multi-generation garbage collector like it is with G1 or Parallel, the garbage collectors. But yeah, definitely check that out. Like I said, if you're having issues when it comes to latency, it's definitely worth it. You would just set the JVM, use GDC, then set whatever appropriate heap size, and then you would also want to turn debug logging just to get a better idea of what's actually happening within the JVM when it's actually running. All right, so this is something that all Java developers are absolutely going to love: helpful non-pointer exceptions. That was added back in JDK 14, JEP 358, but we've all ran into them. At some point, you're going to get a null pointer exception, an NPE in production, and it's going to be on a line where there could be multiple values on that line that could be null, and you just don't know what it is. And so what it almost always means is maybe you're lucky you can be able to figure it out all on your system, but sometimes it means you're having to add like a debug line or two saying like all the different values on a line to make sure to see which one is sometimes coming up null, puts out to production, then fix it and all that. But now with helpful non-pointer exceptions, instead of just it coming back saying what line the NPE happened on, it will actually say the name of the variable that actually was null, and then what threw the actual null. So like it, like the variable with local one, which is a string, through a NPE when string.length was called. So that makes it so much easier. I definitely agree with Philip that it's just one of those things it's such an easy and big win for developers, because we've all ran into that very frustrating NPE error at some point, and it cost us a bunch of time trying to figure it out. And of course, also what's nice is, so all these things, these are runtime changes. you don't need to recompile any code to get advantage of them. So if you have some sort of your JDK 8 application out there, like the exact same binary can run on Java 17, hopefully, if everything's compatible, and you would get this helpful null pointer error back without recompiling or anything like that as well. So it's not like you have to compile your code in Java 17 or something to get this benefit. AMD Architecture 64 has become increasingly popular. Of course, probably the most prominent example again is with like the MacBook M1 processors that were released last year. But of course, they're also available on Linux, Windows, and all of that. So all the major operating systems now have native support for AMD Architecture 64. And so you should see a noticeable performance improvement by getting to the latest versions of that. And of course, there's also a continuing ongoing support for this. So even if, like, say you're on JDK 11, there's been like a few updates to our support for our AMD architecture for all versions of the different architectures since then. So even upgrading to 17, even if you are on Linux, you could still see a benefit from that. And then also on that is there's just general performance improvements with every new release of Java. Our JVM teams are always looking on how to improve the garbage collectors, the internal JVM, and so on. Again, this is just a simple set top or desktop or whatever, tabletop, there you go, that tabletop run of my application of the Spring Boot Pet Clinic where, yeah, exactly, yeah, yep, you get just a lot of improvements just from the JVM every release. Yeah, thanks for Ted. But yeah, just ran it with like the Spring Boot Pet Clinic app and the literal exact same binary running with Java 8, this version. It took about 8 seconds to start, 8.5 seconds to start up, and 137 seconds to execute. I keep forgetting I need to run this again with Java 17, but with Java 16, it was about 6.5 seconds and 130 seconds to execute. And again, just pure benefit without having to do any recompilation. It's not like I had to recompile this binary in Java 17 to do this. Exact same binary between these two different runtime or test runs. All right, the last major section to cover before the Beyond section is some deprecation removals and some other changes to know about. So the first one is the security manager. It's being deprecated for removal with JDK 17. So it's still in JDK 17 and it's still going to be around for at least a little bit longer, but it's going to be removed at some point in the near future. Of course, you're hearing, oh my God, Java, we're removing the security manager. Does that mean we're opening up security vulnerabilities? And that's not the case. I'm guessing most people haven't heard about the security manager, and even fewer have actually used it. And it really goes back to the days of when Java was being used to run and write applets. And that's no longer really the case. It's mostly, web applications, we're running on our servers. But it just, the way the security manager was set up, fundamentally, it was just too hard to configure. And pretty much everything you could do is kind of been superseded by operating system level controls over access for an application. And it's just much easier to work with that. And the knowledge around that is much more widespread than was the security manager. So we just weren't seeing it being used. There's a big cost to supporting it. So kind of with that, it's just going to be removed here. Like it's marked for removal, and when and how it's going to be removed, that's still to TBD, other than it's going to happen. Similarly with applet API, so back in JDK 9, the applet API was marked as deprecated, and now here at JDK 17, it's marked as for removal. It's basically already been dead for some time because pretty much all modern versions of browsers, I don't think, allow Java applets to be used. So it's just kind of the final point of like we're just going to get rid of it because it's just no longer in use anymore, and it's just not the way Java is used. Nashorn was removed from the JDK I was actually listening to a really interesting podcast, the Java Pub House podcast with Freddie Gumi and Bob Holland. They're interviewing Stuart Marks. Long story short, though, so NASTorrent is actually still being maintained. I don't know if it's actually into OpenJDK, GitHub, or somewhere else, but it's actually still being maintained, maybe at a bit of a lesser level. So if you were actually still depending upon it, you can actually still get that binary and have it running within your JDK. It's just no longer part of the OpenJDK anymore. Yeah. Okay. So I think you're one of the first people I've seen that actually have mentioned the actually having worked with security manager in person. I mean, I did see some of the discussion about it online, but most of the time people are like, I've never heard of this before. Yeah, same. Yeah, now we mess with like Mac OS and all their privacy settings on the operating system, and yeah, see, you don't miss it either. So that's good to hear. And the next is the CMS, which stands for the Clear Mark Sweep Garbage Collector, has been removed. That happened in JK14. And fundamentally, the reason why that happened is the G1 Garbage Collector, which was, again, made default back in JDK 9, just supersedes it. The behavior of the G1 Garbage Collector is just a fundamental improvement over the CMS Garbage Collector. So if it's your organization, you're using the CMS Garbage Collector, just moving to the default G1 Garbage Collector should give you just simply improved performance over that without any noticeable difference or anything like that. It's just better performance. The other changes. So by the other one is now we're going to be strongly encapsulating JDK internals by default. So are further strongly encapsulating. So JDK 16, this no longer illegal access permit was removed as a default JVM argument from it. So that way, and now you'll from the startup of it, and now illegal access permits no longer work. So there's no longer a single argument that, well, relaxes all strong encapsulation. Now, certain critical APIs like Sunmisk Unsafe are still allowed to be reflected into, but otherwise you don't get this the blanket illegal access permits anymore. And eventually it's going to be removed altogether. Again, that's going to be TBD, but right now it's a no-op, and at some future version of Java, the JVM will throw an error if it sees this argument. Of course, if for some reason there's like some library that you're dependent upon that just hasn't been updated yet, or you can't update it to, you can still do adds opens at the command line, saying like adds opens and whatever the library, and then whatever module it needs access to. So there's still backwards compatibility. It's just not that easy escape hatch anymore. It's a way of kind of forcing libraries to update. And of course, the reason we're doing this is to better be able to maintain the language, that if we want to change some sort of internal implementation, we'll be able to more easily do that, because we'll only allow outside libraries access to the API that we actually explicitly declare we want to have other external APIs access to. Oh, one other thing I want to touch on. So I kind of covered like language changes and all of that, but also with every release, there's a bunch of like new classes and new methods and stuff added. Like one of them is like string. It's had a whole lot of new helper methods have been added to it since JDK 11. So starting with JDK 17, there was also the new, I believe it's called the new API, where within like the official Java docs, you can see like all the new modules, packages, interfaces, classes, and so on that have been added to the JDK, and you can even break it down by which version of the JDK these things were added in. So this is actually very helpful, both just to see what all has changed, but then there's a lot of very helpful changes within that as well that have been added to Java. over recent releases that I just don't really have time to cover because we would be here for like hours then. All right. The last part is we're going to get a little bit into the future of Java and what's going to be kind of coming. And this is the near future, not the far future, many years from now. Yeah, it is a really awesome page. Like it's kind of been supported, or there's already been something similar, like the Java Almanac, that's been kind of available, which filled a similar niche. But now it's available on official documentation, and then also this is probably more of a case if you're a library developer, but Java doc, and you can do -- since to show the difference in your API or any differences in your library or whatever that have been changed in recent releases as well. So it's not just something that is available to us as a maintainers of Java, but it's actually available to anyone for when you're building out your Java doc. So that's also what's pretty cool. But yeah, the last part is the future, and this is mostly the near future. The stuff that's going to be coming in the next few releases are that is already available as preview. And so one of them, so like the big project that's going to be talking about is Project Amber. And that's where a lot of these new language features are coming out of, like records, switch expressions, and pattern matching. So one of them is pattern matching for switch expressions, and it's going to be adding like guard patterns and being it like we see here, where you could also actually have and ors and all that stuff within your case labels. So if like, okay, if it's a type of triangle and that triangle has an area of a 100 or greater, then execute this case statement. Otherwise, if it's just a triangle, whatever, execute it and on. Obviously, you can't have a case dominate all subsequent cases. So if I was to put triangle T in front of here, well, then I would get a compiler error on this case statement, because obviously by definition, if this will be true before this will be to be called. We can also handle null case labels. And I guess I don't show the example here, but I was just showing also sealed classes. So like, let's say I was to do a switch on user, instead of having to have like a default case in here, I could just do, say, guest, customer, and admin, and then that wouldn't need a default case because I covered all the different possible subtypes, immediate subtypes of user within that. So that's how some of these individual pieces that are kind of useful on their own, but they're going to kind of come together in future releases of Java to be even more useful together. Record patterns and array patterns. So that's a preview that's coming in Java 18. And you can be able to like directly reference an element with an array. So instead of having to say like, oh, okay, here's an array, and then, the array, and then calling the elements like we have here, you can just directly reference it with like that instance of saying like, okay, S1, S2, that will refer to like the first element, the second element, and so on within that array, which is just a little bit cleaner and easier to work with. It'll also be a little bit easier then to define records and kind of assign values to them. And I don't think and then also coming will be deconstruction patterns for records. So it'd be much easier to reference values within a record and pulling them out as needed, instead of maybe always having to call each of the constructor or each of the accessors as well. I think this was written back in either 2019 or 2018 but Brian Getz, the chief language architect for Java, lays out really the story for pattern matching. And you can see here, even though this is written like in 2018 or 2019, you can actually see how some of these things like records and some pattern matching has already been implemented. And you can then also see like, oh, okay, so yeah, this is where we're actually going to be going here over the next few releases of Java. So also the other thing to think about is early access builds. So JDK 18 is already available, as are for some of the other major projects. So there's Loom, and that deals with virtual threads, and that's going to really be a huge game changer for when it comes to parallelization for Java, when it's finally going to be added in. Panama deals with native APIs, and then Valhalla deals with value types. But all these, like, we're always happy to hear feedback. If like some of these things are going to be particularly interesting to you, if there's some features coming in Java 18 you really want to check out, virtual threads are really important. If you're an organization that really cares about native APIs or something like that, Panama, definitely check this out. And you'll be like, hey, oh wait, I'm getting some sort of issue here, or it would be really great to do something like this. Like, that's really important and valuable feedback for us. So if that stuff matters, or is something you're interested in, definitely check out some of these early access builds, and then be a way to give feedback to us, which again, something we would very much value and appreciate. So some code examples. So again, a link to this slide deck can be found here. As I mentioned, the JDK examples. Oh, cool. So yeah, Project Panel. So yeah, that again, that's a really great way to kind of work together. Yeah, that's right, with Carl. Carl is really awesome. I finally got to meet him in person here just recently in KCDC, and he's a really nice guy. But yeah, so you'll get to learn about Panama, and then maybe actually then check it out as well. Also check out the release notes for every release. Just a lot of really great information within them that really obviously goes into great detail what's happening, and it also gives you links off to like do the Java language specification, which can be really helpful for knowing exactly how something works, or how something is supposed to be used. As I mentioned, my SIPA Java, I'll probably need to update this link soon, but as I'm migrating it to a new site that's going to contain everything for them. Also, one last thing is, I know there's a lot of concern when it comes to upgrading beyond Java 8. I'm sure many people here are probably using still on Java 8 at their organizations. And so this is a really great blog article by a Netflix engineer, where even Netflix was actually struggling, or at least perceived to be, or thinking it's going to be a big issue to upgrade beyond 8, where this Netflix engineer was saying like, oh, like you saw they were using Java 8, and like people just thought it was impossible to move beyond Java 8 to Java 11. Like in this example, and really what it kind of comes down to, what he kind of details in this article, is it's just mostly upgrading your dependencies. For, of course, there's many millions of dependencies and libraries out there. So obviously not all of them have been updated, but for many of the most popular ones, your Spring, your Jakarta EE, all of that, like a lot of those have all been updated to run on, Java 17 really and beyond. And in fact, the next major releases of Spring 6, Spring Boot 3 are actually going to be running on Java 17. So a lot of it is just about upgrading your dependencies to be able to kind of run them. And, maybe that's sometimes some code changes as well to go with the upgraded dependencies, but it's not quite as big of a change as people, the concern is. And, always a big goal within Java is the backwards compatibility. So usually it's going to be relatively few code changes to be enforced by the JDK itself. So with that, I'd be happy to answer any questions you might have.
Awesome. Yeah, if anyone has any questions, please feel free to leave them in the chat, or you can even unmute and talk to us.
yeah, definitely at this point, feel free to unmute for sure.
And I did want to second the testing early builds of Java. Definitely do that. And I think there's even the quality outreach programs. If anyone works in any open source projects, you can help by testing and certifying that your open source projects do indeed work on early releases. And I know that definitely helps.
Yeah. And at least a good example also of how we do take that feedback in is I think with Java 11 or 12. So like I showed text blocks earlier, and initially we were supposed to, the initial feature for text blocks was what's called raw strings. And we put out a preview for that, but then based upon feedback from the community, that actually led to that kind of feature being withdrawn and eventually it became text blocks. So that's an example of how some of that stuff changes. And then also for every new language feature, we always do 2 previews of it. And there's always, little tweaks and changes based upon, again, community feedback for that. Probably something I need to really add to this presentation is kind of how to work with preview features. But there is some documentation out there on how to do that. And again, it's always important to get that feedback to make sure that, we kind of get these things right. And it's really kind of nice that we can kind of get the stuff out a little bit earlier to kind of get these little things kind of ironed out a little bit better, because that's kind of how certain things like fall through by default. Like if we could go back in time, we wouldn't probably have done fall through by default. Here's the link to my slide deck, Don. We probably wouldn't have done that because that's really not the way most Java developers really want to interact with case statements. But because we really didn't have that feedback mechanism at the time, that's something that went through. Another big one is serialization. We probably would have done serialization completely differently if we could have gotten some good feedback. So all that to say is that we really do want to hear that feedback. I'm not just saying that just as like a checkbox, like please send up feedback, because that's how we make Java better. All right. Well, of course, if you have any more questions, feel free to DM me at Billy Korando on Twitter. My DMs are open, and I'm on Twitter way too much, so I'll probably be able to get back to your message pretty quickly. And of course, also, if you're not on Twitter or you just prefer email, billy.korando@oracle.com, you can reach me there as well. But yeah, thanks so much. And hopefully next time I'll be able to actually speak in person at Pittsburgh Jug.
Yeah. Thank you so much, Billy. That was really good. It's a crash course almost of seeing all the features.
I only cover a few, and there's several others that we'd like to cover, but
no,
it's a lot already.
that was really great. In fact, I was surprised how you did not lead with like records. I was like, wait, he's not even going to bring it up, or is he probably teasing us like all the way?
Sarisha was offended.
How dare he? I know. No, it's a last, but definitely not least, just because there's a lot to cover there.
No, absolutely enjoyed that. And of course, I think a couple of them already said that helpful null pointer exceptions is going to be one of the best things for us for production code. So
that's the kind of feature where you're like, why wasn't that a thing?
And we have to do this manually, right, for the longest time. So anyway, thanks a lot, Billy. Thank you for joining us, and hopefully we'll see some of our attendees in our next session where we'll talk about Project Panama from Caldia. So
great.
Thank you.
Awesome. Thanks so much. All right. See you all later. Bye.
Bye-bye.